Hey everyone, welcome back to Daily Dose of Space. Today we've got a powerful mix of cosmic discoveries. We'll look at Apep, a chaotic triple-star system wrapped in spiraling dust shells revealed by the James Webb Telescope. Then we'll jump to a young solar system-like star, where astronomers captured a baby planet, WISPIT 2b, still forming inside its dusty rings. And finally, an interstellar visitor, Comet 3I Atlas, whose ion tail might actually be crossed by two spacecraft in the coming weeks, giving us the first ever in situ data from an object born outside our solar system. 3 stories, 1 theme. The universe is still shaping itself right in front of us. Apep, the chaotic dust spiral. Apep is a system of 2 Wolf-Rayet stars, massive dying stars that throw off strong stellar winds, and, as revealed by JWST, a third massive star bound to them. What makes Apep remarkable are the 4-coiled dust shells spiraling outward, revealed for the first time in mid-infrared by Webb. These dust shells are made of carbon-rich material and are ejected over a long cycle as the 2 Wolf-Rayet stars arc near each other every 190 years. But there's a twist. A third star, a supergiant, carves holes into these expanding shells as it orbits, creating a complex, almost sliced pattern in the dust. This structure isn't just beautiful, it reveals how colliding stellar winds and orbital dynamics sculpt dust in real time. Something we rarely get to observe this clearly. Over time, these dust shells may contribute carbon-rich material back into interstellar space, helping seed future generations of stars and planets. WISPIT 2b, a baby planet in its cradle. Moving on to a very different part of the universe, WISPIT 2, a young sun-like star system. Astronomers observed it using the ESO Very Large Telescope and discovered a planet still forming inside a multi-ringed protoplanetary disk. This planet, named WISPIT 2b, is about 4.9 Jupiter masses, and evidence shows it's actively accreting gas. Basically, it's gobbling up material from its dusty environment. What makes this discovery extraordinary is how clearly it sits in a gap within the dust rings, a spot that many theorists predict for young, growing planets. Because it's so embedded, researchers can study how the planet interacts with the disk. Do these rings mark where planets clear gaps? How does the disk's material flow? WISPIT 2b gives us a real-time laboratory to watch planet formation in action. This system could become a cornerstone for our understanding of how gas giants form around young stars, especially because we rarely catch planets this early and in such a clear, multi-ring environment. 3E Atlas, a comet's ion tail and spacecraft rendezvous. Now let's shift to something even more interstellar. 3I Atlas. This comet is on a hyperbolic path through our solar system, and according to recent research, there may be a window for in situ measurements by spacecraft. Scientists predict that Europa Clipper could cross through the comet's ion tail between October 30th and November 6th, 2025. The ion tail is made of charged particles, plasma, and if Clipper flies through it, it could detect changes in the solar wind, magnetic draping, and potentially see a structure that tells us something fundamental about comet-solar interactions. There's also a chance for the Hera spacecraft, the European mission, to sample this tail between October 25th and November 1st. If successful, this would be the first time a spacecraft collects direct data from an interstellar comet's ion tail, giving us information about how it interacts with magnetic fields, how it loses mass, and how its particles behave. It's a rare and powerful opportunity, not just for comet science, but for understanding how objects from outside our solar system behave when exposed to solar wind. So, today we've seen a kind of cosmic choreography. Apep, where dying stars spiral out dust in four coiled shells sculpted by orbiting companions. WISPIT 2b, a newborn giant planet building itself inside a dusty, multi-ringed disk. 3I Atlas, an interstellar comet whose ion tail might be sampled by spacecraft, offering a once-in-a-lifetime data opportunity. These stories might seem totally separate, but they all speak to the same truth. Space is not static. Stars die and shed. Planets are born. Interstellar visitors cross our paths. We're not just watching a universe that is, we're watching one that lives. Thanks for tuning in to Daily Dose of Space. If you want to keep up with cosmic discoveries, don't forget to subscribe. I'll see you in the next episode.